The last one we learned was substitution, and now what we'll be looking at is elimination. And you see the steps here, and you can read through those. I think they'll make more sense as we work through some examples. You don't always need all the steps, as you'll see. Sometimes it says if necessary. So we'll follow each step for this first one as I work through this example. And the idea is we're going to eliminate one of the variables to start with. So we want to get to an equation that just has an x in it or just has a y. And it doesn't matter which one. Just because in a couple of these examples we might eliminate y each time, doesn't mean you can't eliminate x in other ones. So we don't need to multiply both sides of the equation in this case. What we want here is the same coefficient with opposite signs. Or with the same sign, it doesn't matter, but opposite signs is the nicest. So what we're going to do is we're going to go to the second step and we're going to add or subtract the equations to eliminate one variable. We see here that there's a y and a negative y. Well, this x plus y is equal to 4, x minus y equals 10, and so 10 equals x minus y. So we're just using the addition property of equality. We're adding the same thing to both sides, and we can have it look like this. And we're just going to add down here, and we add like terms. They're nice. This is set up nice for us, as many of them will be, where the like terms are just lined up. So x plus x is 2x. Y minus y is 0, so we don't even need to put that there. And that's what we wanted. We wanted a variable to eliminate completely. And then 4 plus 10 is 14. And then to solve, so now we're here, solve the resulting equation for the remaining variables. So we're dividing both sides by 2. And we get x is equal to 7. So that was really easy to find the x value. We are not finished yet because we need to find the y value. So substitute the value found, so x equals 7, into either of the original equations and solve for the other variable. So we're going to come up, I think this one looks easy to work with. It doesn't matter which equation, but we're going to take x plus y equals 4. But what we can do here, instead of putting x here, we can substitute in and put 7 plus y equals 4. We'll subtract 7 from both sides. And we get y equals negative 3. It says write the solution as an ordered pair. So 7 is our x value and negative 3 is our y value. So that's our answer. And check the solution in all equations. So let's come over here. We have x is 7, y is negative 3. So 7 plus negative 3 does in fact equal 4. And the next one, 7 minus negative 3. Let's write that one, 7 minus negative 3. Does that equal 10? Well, yeah, because minus a negative is plus, so this is really 7 plus 3. And it does equal 10. So that checks, and that is our solution. Moving on to the next one. Once again, if necessary, multiply both sides by 1 or both sides of one or both equations so that the coefficient of the variable to be eliminated have the same absolute value. It really means the same number. So here we have 3x here and a 3x here. So we're in good shape. We don't need to multiply anything. Add or subtract the equations. Well, how do we know if we add or subtract? Well, what we want to do is we want to eliminate the ones that have the same coefficient here. So if we added 3x plus 3x, we would get 6x, which we don't want. So what we're going to do here is we're going to subtract. Some people will do this different ways. I'm okay with just subtracting. You also can think you're multiplying this bottom one by negative 1, which if you do, it changes all the signs. And so now if you do that, you can just add. So 3x minus 3x, or 3x plus negative 3x is 0. 2y plus negative 5y is negative 3y. And 8 plus negative 14 is negative 6. So we added, or we can subtract, whichever way you're thinking of it. Solve the resulting equation. Well, that's nice and simple. Divide both sides by negative 3. And we get y equals negative 6 divided by negative 3 is a positive 2. And then we're going to take this 2 and substitute it back into either one of these equations. So let's put it in the second one this time. And I put it in the original without the negatives. And so we'll put a 2 in for y, because we found y was equal to 2. This is just equal to 10, so I'm going to subtract 10 from both sides. And we have 3x equals 14 minus 10 is 4. And we divide both sides by 3, and we get x is 4/3. And we can write our answer as an ordered pair. 4/3 was x, and 2 is our y value. And then we can go ahead and check this. So we're going to check, and we're going to put these numbers in. So we have 3 times x, which is 4/3. So I'm using this first equation, plus 2 times y, which we found was 2. And we want to see, does that equal 8? Well, 3 times 4/3, we can think of this over 1. So this is 12 over 3, which is really just 4, plus 2 times 2 is 4, which is equal to 8. So that works. And now we want to test the other one. So we have 3 times 4/3 plus 5 times 2 is equal to 14. Another way to think of this, the 3 cancels with the 3, and so we have 4 plus 10 does in fact equal to 14. So this solution, 4/3 2 is the answer. Our next one, this is the first one where we actually have to do something with this first step. Notice here we have a 2x and a 5x, a 3y, and a 6y. None of those are the same coefficient or opposite coefficients. So what we need to do is we need to multiply one or both of the equations by something so they do have the same coefficient. You can do it either way, but there's an easier way here. Notice 3y. If we multiply 3y by 2, we would get 6. And that would be good because this is a 6y. So in fact, it's even nicer if this was a -6. So what we're going to do is we're going to take this first equation and multiply both sides by -2. And in order to set this up nicely, I'm going to go ahead and rewrite both equations. So this one, multiplying by -2 is -4x minus 6y equals -8. And then the bottom one, we didn't do anything to. This is 5x plus 6y equals 7. The reason we, again, did that was we multiplied by -2. So now here, if you look here, there's a -6y and a +6y. We wanted these to have either the exact same coefficient or opposites, and now they have opposites. So now this is like the other ones. We can just add -4x plus 5x is 1x, or just x. -6y plus 6y is 0. And then -8 plus 7 is -1. Well, that worked out nice. It's already solved for us. X is equal to -1. Now what we can do is we can take that -1 and put it into either equation. Let's go with the bottom this time. So we're going to do 5x. Well, x is -1, we just found, plus 6y equals 7. 5 times -1 is -5, plus 6y equals 7. We would go ahead and add 5 to both sides. And we get 6y equals 12. And thinking through that, or dividing both sides by 6, we get y is equal to 2. And so our solution there is -1, 2. And again, we could check it. I'll do it kind of quickly here. 2 times -1, so I'm putting it into the first equation. 2 times -1 plus 3 times 2. Does that equal 4? Well, we have -2 plus 6. That does in fact equal 4, so it works there. Now putting it in the second one, 5 times x, which was -1, plus 6 times 2, putting 2 in for y. We want to check, does that equal 7? And this is negative 5 plus 12, and that does equal 7, so they both work. So this is our answer. And so in this one, we did have to multiply both sides by negative 2 in order for the y coefficients to be the same. This next one takes it one step further. If we look here, we have a 2x and a negative 3x, a negative 3y, and a 7y. 2x, there's not a nice whole number or integer that we can multiply to get negative 3 or 3. We can't multiply 3 by something, an integer, to get 7. So in this case, we're going to multiply both equations by something. Now we have two options. We could eliminate the x's or we could eliminate the y's. I'm going to go ahead and eliminate the x's here. So looking at these numbers, we have a 2x and a negative 3x. So we want to think, what number does both of those go into? And both of those numbers go into 6. So we would like to make these 6's. Well, how do we make a 2x 6? Well, we can multiply both sides by 3. And that's like multiplying each term by 3. You could think of it that way. Or we could multiply the whole side by 3. So on the top, we get 6x minus 9y is equal to 3. On the bottom, we want to get this negative 3 to have a 6. And having negative 6 would be fine. So how do we get that? Well, we would multiply the whole thing by 2, both sides by 2. That gives us negative 6x plus 14y is equal to negative 18. And now we have two coefficients that are opposite, so we can go ahead and add these equations. 6x plus negative 6x is 0. Some people like to just cross those out because they're 0. Negative 9y plus 14y, that's 5y. And 3 and negative 18 is negative 15. Dividing both sides by 5, we get y is equal to negative 3. And now we'll go ahead and substitute. So let's take our first equation, 2x minus 3y. Well, y is, we found to be negative 3, equals 1. So we get 2x plus 9 equals 1. We'll subtract 9 from both sides. We get 2x equals negative 8. And dividing both sides by 2, we get a value of x is equal to negative 4. So our solution is negative 4, negative 3. And once again, you could go back and check that to make sure it works in both equations. And that is solving by elimination. You want coefficients that are the same. And then you add or subtract. We've been doing a lot of adding because we made our signs to be opposite, so you can just add. And then we solve. The rest of it's pretty simple. You solve the resulting equation. So we solve something like this. And then we take this back in, and we actually do some substitution then, because we take negative 3 and put it back into one of the y values. And you were able to find x then.